Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents the short conference, Dunning-Kruger, the illusion of genius thanks to artificial intelligence. The greatest enemy of knowledge is not ignorance, it is the illusion of knowledge. By Stephen Hawking. Justin Kruger and David Dunning are most known for co-authoring research on the Dunning-Kruger effect, a cognitive bias where individuals with low ability in a specific area tend to overestimate their competence, while those with high ability often underestimate their skills. The dictatorship of non-planning, or the unenlightened despot. The Dunning-Kruger effect contributes to dictatorial leadership and the perpetuation of authoritarian power. This phenomenon is increasing rapidly, supported by the ochlocracy of social media, which means that the most qualified people can be looked down upon, or ignored, due to a lack of awareness of their own worth. In the political context, Dunning-Kruger brings many incompetent people to power, led by an incompetent person supported by excessive confidence, which makes him lacks the experience and knowledge necessary to govern. On the psychological inability to recognize his mistakes and lies, and ignores the validity of the opinions of a third party, whoever they may be. The unenlightened despot ignores and despises this knowledge. The Dunning-Kruger effect is a cognitive bias in which people with limited skills or knowledge in one area tend to overestimate their own competence. This phenomenon was documented in 1999 by psychologists David Dunning and Justin Kruger, from Cornell University. The core of his theory is that the same incompetence that leads someone to make mistakes prevents him from having the metacognition tools necessary to recognize those failures. In short, the Dunning-Kruger effect contributes to dictatorial leadership and the perpetuation of authoritarian power. This phenomenon is increasing rapidly, supported by the ochlocracy of social networks that means that the most qualified people can be belittled or ignored due to a lack of awareness of their own worth. In short, the Dunning-Kruger effect contributes to dictatorial leadership and the perpetuation of authoritarian power. This phenomenon is increasing rapidly, supported by the ochlocracy of social networks that means that the most qualified people can be belittled or ignored due to a lack of awareness of their own worth. According to Dunning and Kruger's original paper, the phenomenon can be summarized in 4 basic premises regarding low-achieving individuals. Overvaluation: they tend to overestimate their own intellectual or technical abilities. I know everything. External blindness: they cannot recognize true competence in others. It's starting to make sense. Internal blindness: they cannot measure the severity of their own shortcomings. I'm never going to understand this. Late acceptance: if they receive formal training in this area, they can recognize and admit their ignorance. Trust me, it's complicated. The Dunning-Kruger effect is based on 2 principles. Incompetence: people who don't have real knowledge or skill in a given area tend to overestimate their competence. Inability to recognize one's own incompetence. The lack of metacognitive skills prevents these people from recognizing their own limitations. The Dunning-Kruger effect is represented by a curve that describes the relationship between a person's self-confidence and their actual knowledge. The phases of knowledge are: the peak of stupidity occurs when the person learns a little about a new topic. The person experiences a burst of utmost confidence and feels like an expert without realizing the true complexity of the matter. The valley of despair: by continuing to study, the individual discovers the immensity of the subject. Trust plummets when you realize your own ignorance, and a new stage begins, the slope of the lighting. Through constant effort, the person acquires real knowledge. Trust is slowly but surely beginning to recover. The consolidation plateau: the person attains expert status. Interestingly, in this phase the reverse effect or imposter syndrome is usually experienced, where the specialist underestimates their ability thinking that the problem is obvious to everyone. Experiments show that the Dunning-Kruger effect generates the belief that IQ has a higher value than it does. It's hard to win an argument with a smart person, but is damn near impossible to win an argument with a stupid person. By Bill Murray. Modeling the Dunning-Kruger effect, a rational account of inaccurate self-assessment. It is a key paper of this section. Assessing one's ability on a task is widely perceived as a foundational skill, but most studies find that people are poorly calibrated according to their own abilities. Some results seem to show worse calibration for low performers than for high performers. This effect has been explained in several ways. It could indicate lower metacognitive ability among those who are low performers. To clarify these explanations, a Bayesian model of evaluation was developed. The results suggest that poor assessment is caused by the influence of previous beliefs and an imperfect ability to determine whether a problem was solved correctly or not, and only offer weak support for the relationship between metacognitive ability and performance. It has generally been found that people are poorly calibrated in their ability to judge their own performance in many areas. Dunning, Heath, and Souls, in 2004. However, the possible causes of this phenomenon do not usually coincide. Dunning-Kruger, in 1999, found that the worst employees tended to be less calibrated in their ability to judge their performance than the best performers. They interpreted the perceived poor performance of the individuals with the lowest score as a metacognitive deficit. The worst employees lacked the skills necessary to perform the task correctly, and to judge their performance on it. Kruger and Muller, in 2002, disagreed with this conclusion, arguing that the cause was mere regression to the mean. Dunning-Kruger, in 2002, argued that this explanation did not yet explain their original results. Resolving this debate requires designing a quantitative explanation of self-assessment that clarifies the dependence between capacity and calibration. Adopting a computational modeling approach allows theories about how performance and self-assessment are related to experimental results to be directly compared. It is assumed that people's inferences about their ability are based on the correctness of their answers, their beliefs about their own ability, and the difficulty of the task they are performing. To model what a rational agent would do, a Bayesian formulation is used, which models an evaluation, based on knowledge, about its capacity and the difficulty of such evaluation, a priori information, and their performance in each individual problem, likelihood function, and a posteriori information. The figure shows the graphical representation of the model. Each XPI observed response is influenced by latent beta I variables, drawn from the difficulty prior, and theta p, perceived ability prior, as well as a constant epsilon, the likelihood. Beta I is extracted from a normal distribution, with mean mu b and standard deviation sigma b and theta p. Beta I is normal with mean mu q and sigma q standard deviation. 3 types of experiments were realized: baseline model, change prior information, and change likelihood. The figure shows the model predictions for A. The baseline model. A Monte Carlo Markov string is used to sample from the posterior on the perceived capacity theta p. For different scores in an assessment, we retrieve a somewhat inaccurate estimation pattern of performance. For each possible score of 10, the model samples the perceived ability theta p and a beta is vector, and then integrated beta to obtain a marginal distribution over theta p. Then convert each theta p parameter into the probability of a correct answer. Epsilon is equal to 0, as though participants have perfect assumptions about their performance on each problem, and we assume theta p and each beta I are distributed normally with mu q, and mu b equal to 0 and theta p equal to 1. The figure shows the model predictions for A. The baseline model. A Monte Carlo Markov string is used to sample from the posterior on the perceived capacity theta p. For different scores in an assessment, we retrieve a somewhat inaccurate estimation pattern of performance. For each possible score of 10, the model samples the perceived ability theta p and a beta is vector, and then integrated beta to obtain a marginal distribution over theta p. Then convert each theta p parameter into the probability of a correct answer. Epsilon is equal to 0, as though participants have perfect assumptions about their performance on each problem, and we assume theta p and each beta I are distributed normally with mu q, and mu b equal to 0 and theta p equal to 1. The figure shows the model predictions for A. The baseline model. A Monte Carlo Markov string is used to sample from the posterior on the perceived capacity theta p. For different scores in an assessment, we retrieve a somewhat inaccurate estimation pattern of performance. For each possible score of 10, the model samples the perceived ability theta p and a beta is vector, and then integrated beta to obtain a marginal distribution over theta p. Then convert each theta p parameter into the probability of a correct answer. Epsilon is equal to 0, as though participants have perfect assumptions about their performance on each problem, and we assume theta p and each beta I are distributed normally with mu q, and mu b equal to 0 and theta p equal to 1. The model predicts that people will inaccurately estimate their performance due to a combination of the effect of previous beliefs about their ability and an imperfect ability to guess their performance on each individual problem. To see how well models with different parameters capture reality, one condition replicates the approach taken in previous work. In another condition, participants received immediate feedback after each problem. In the model, this can be interpreted as a reduction of the epsilon parameter. If people know whether they were right or wrong, epsilon should indeed be 0. A total of 100 participants, 50 per condition, were recruited from Amazon's Mechanical Turk, M-Turk, and each received $3 for their time. To compensate for the fact that these were M-Turk participants, some of whom were trying to complete the task as quickly as possible to get paid, those who spent less than 10 minutes on the task were removed. In addition, since the Dunning-Kruger population were undergraduate students, anyone who indicated that they had attended law school or taken the law school admissions test, LSAT, was excluded. All participants completed 20 logical reasoning problems adapted from the 2007 LSAT. All participants rated their absolute ability through the following questions: how many of the 20 problems did you answer correctly? How is your relative ability compared to other participants? How well do you think you did? The difficulty of the task for themselves, and the difficulty for others. To analyze self-assessment, the focus was on absolute capacity assessments. At the conclusion of the study, participants were directed to a short demographic questionnaire. The no feedback condition is a direct reproduction of the design used in previous studies, in which participants received immediate feedback after each problem, which consisted simply of learning whether their answer was correct or not. The figure shows participants' score estimates, out of 20, based on the actual score, compared to the model's best predictions in A. No feedback, and B. With feedback conditions. The feedback model is known to reduce the dispersion of results. Experiment baseline. The figure shows the mean estimates of score, out of 20, by quartile of actual performance in A. No feedback, and B. With feedback. The model data was compared to participants' estimates of their scores relative to their actual score. The results of self-assessment studies usually organize their data by performance quartile. However, this representation of the data removes much of its nuance. Error bars show 95% confidence intervals. The mean completion time was 38 minutes for the 93 participants included in the analyses: 55 males, 35 females, 2 others, and 1 unspecified. Mean age equals 33.33 years. Participants correctly answered 9.90 problems out of 20, standard deviation 3.99, and the average perceived score was 8.54, standard deviation 3.99. The difference between the actual score and the perceived score was considered significant by a t-hypothesis test. This pattern of underestimation held in both conditions, without and with feedback. The overconfidence test of the worst outcomes was limited, as this logical reasoning test was significantly more difficult than the one used by Dunning-Kruger in 1999. Therefore, the classic Dunning-Kruger effect, overestimation by the worst participants, was not observed. The Dunning-Kruger effect and artificial intelligence. The Dunning-Kruger effect in large language models, an empirical study of confidence calibration. It is a key paper of this section. Large language models, LLMs, have demonstrated remarkable capabilities in various tasks, but their ability to accurately assess their own confidence remains poorly understood. The LLMs exhibit patterns reminiscent of the Dunning-Kruger effect, a cognitive bias in which people with limited competence tend to overestimate their abilities. 4 state-of-the-art models, Claude Haiku 4.5, Gemini 2.5 Pro, Gemini 2.5 Flash and Kimi K2, are evaluated across 4 reference datasets totaling 24,000 experimental trials. The results reveal notable calibration differences. Kimi K2 shows severe overconfidence with an expected calibration error, ECE, of 0.726 despite only 23.3% accuracy, while Claude Haiku 4.5 achieves the best ECE equals 0.122, with 75.4% accuracy. These findings demonstrate that low-performing models show markedly higher patterns of overconfidence, analogous to the Dunning-Kruger effect in human cognition. 4 large language models representing different architectural approaches was studied. Claude Haiku 4.5, Anthropic, a compact model optimized for efficiency while maintaining strong reasoning capabilities. Gemini 2.5 Pro, Google's flagship reasoning model with advanced multi-step problem-solving capabilities. Gemini 2.5 Flash, Google, a faster variant designed for rapid inference while preserving accuracy. Kimi K2, Moonshot AI, a reasoning-focused model with extended thinking capabilities. All models were accessed through their respective APIs with the temperatures set to 0.0, ensure deterministic results and maximize reproducibility. The figure shows the confidence versus accuracy across models, demonstrating the Dunning-Kruger effect. The diagonal line represents perfect calibration. Kimi K2 shows severe overconfidence, top left quadrant, while Claude Haiku 4.5 exhibits near optimal calibration. The figure shows the ECE comparison across models. Lower values indicate better calibration. Claude Haiku 4.5 achieves the best calibration, while Kimi K2 shows severe miscalibration. The figure shows the reliability diagrams for Claude Haiku 4.5, left, and Kimi K2, right. The diagonal represents perfect calibration. Claude Haiku 4.5 shows well-distributed confidence with close adherence to the diagonal, while Kimi K2 shows severe overconfidence with most responses clustered at high confidence despite low accuracy. The study on confidence calibration in large language models, LLM, reveals surprising evidence of Dunning-Kruger-like patterns. The Dunning-Kruger effect has been remarkably visible in recent years, especially in the field of artificial intelligence, AI. The term AI-driven has become a central buzzword in sales presentations, often used without sufficient understanding. This trend reflects a troubling mix of incompetence, misunderstandings, and exaggerations about how AI works. Dunning-Kruger effect 2.0, the illusion of omnipotence in the age of AI. In the traditional growth curve of engineering, there was always one clear and inevitable phase, the valley of despair. It was that moment when a new technology was released thinking you got it, only to be crushed by cryptic error logs, unresolvable merge conflicts, and legacy code that looked like ancient ruins. The signal was being learned. It was the crucial moment of the realization, I don't know anything. But in 2026, that valley has been paved by AI. If you run into a bug, the AI explains it to you instantly, and we can run forward in a continuous state of it just works without ever reaching the despair that triggers deep, structural growth. This is the Dunning-Kruger effect 2.0. Unlike the classical psychological phenomenon, overconfidence born of ignorance, this is a structural illusion of competence caused by powerful intellectual crutches. The phenomenon, illusion of competence. Recent research in cognitive science has begun to reveal an unsettling reality about how we interact with increased intelligence. The paradox of skill degradation. Studies in 2025 showed a stark contrast. Groups using AI tools report significantly higher self-assessment scores after completing tasks compared to groups that don't. However, when those same people are given a retention test without AI, their performance scores plummet. AI doesn't just act as a tool, it works as an alternate circuit for our brain. This phenomenon is known as cognitive download. The I think I get it mechanism. Why does this happen? Instant gratification. The time spent on productive struggle is reduced to zero, the code works immediately. Friction disappears, because we don't have to think about why it works, the brain avoids the mental effort needed to process and store new information. Pseudo-fluency, reading a fluent and confident explanation generated by an LLM tricks the brain into believing that it has systematically understood the underlying concept. As a result, we fall into a dangerous state, confusing AI production with our own knowledge. The tragedy, the rise of the hollow senior. The worst case scenario of this illusion is the mass production of what I call senior hollow engineers. They are developers who carry the title and speed of a senior, but lack depth. AI might just be the Dunning-Kruger effect's greatest accelerant. We've all been to that meeting. Someone at the table has spent a weekend with a generative pertainer transformer, GPT. They are full of energy, convinced. Suddenly, they're the experts in the room, reshaping strategy, discarding years of hard-earned experience, and confidently declaring that everything you've built is obsolete. This is the Dunning-Kruger effect in full collapse, and the AI is adding more fuel to it. For example, a public sector organization makes bold decisions. It believes it doesn't need a data infrastructure governed by certified data sources. There are no structured pipelines. It's an understandable decision. AI feels magical. Ask something and get an answer. Why spend months building databases when the machine can do it instantly? The Dunning-Kruger effect can manifest itself in different ways when it comes to GPT. Some people may overestimate the capabilities of the technology, and assume that it can provide accurate and complete answers to any question, regardless of its complexity. They may believe that GPT understands the emotional context of a conversation, and provide appropriate responses, even if the technology is not yet sophisticated enough to do so reliably. Currently, the union between the Dunning-Kruger effect and artificial intelligence raises the question of what it will produce, an AI genius or a fake. Remember, all science as it grows toward perfection becomes mathematical in its ideas. Alfred Whitehead. Thank you very much for your attention.